In this video, we are going to practice solving triangles using the law of sines, but we're going to be dealing with the ambiguous case. That's when you're given side angle information, two sides and the non-included angle. Really, anytime you're given two sides and an angle, it's very likely that's going to be the ambiguous case. So here's what I want you to do. Focus on the angle. Draw that angle first and draw it to the left just to be like me. Okay, so I will draw a horizontal line and then I'm going to draw my angle on the left hand side like this. Alright, so this is called angle A, and so I've got my 25 right here. Now take this open side, pretend this is a hinge, and I'm going to call this my swing side, because I'm going to imagine that it could swing back and forth like this. Okay, now if this is angle A, then this must be side A, because it's across. So that's why I know that this will be 125. Now, let your other side be the rigid side. Rigid means non-moving. So this was my swing side, and this is my rigid side. I'm going to let the rigid side be 150. Since this is side B, that means this must be angle B. That just leaves angle C. So before we do anything else, let's decide whether this would make a triangle at all before I waste any time solving anything. Here's how I can tell if it'll make a triangle at all. Let's consider the height of this triangle. I'm going to call it h. We can calculate this using the sine function. Sine of 25 is going to equal opposite over hypotenuse. So that's h over 150. If I multiply both sides by 150, I'm going to get 150 sine 25 is equal to the height. So I'm just going to put this in my calculator real quick. 150 sine 25. So that's telling me that the height is 63.393. Okay, so the height is about 63.4. So will this make a triangle? Basically, I'm asking, will the swing side reach across this distance? And yes, if this were a rope, this would be a 125, let's say, foot rope. But the height of the triangle is only 63.4. So 125 will definitely reach all the way across. So we will have at least one triangle. The question is, will we have two triangles? Well, here's how you could wind up with two triangles. Remember, we're going to treat this like a swing. It's a swing side. So if the swing side were to swing inside the triangle, if this is valid, then we'll have a second triangle that's skinnier. So that would mean that this pink was 125 because we just swung it like this. Now, would this make sense? Yes, this would work. The rigid side is 150. That is longer than this. So 125 will definitely fit underneath this because it's less than 150. So we will have two triangles. We'll have one triangle on the outside, shown here in blue, and then we'll have another triangle with it on the inside. So what I'm going to do is I'm going to actually draw the second triangle. So the blue outer triangle, that's one triangle. I'll go ahead and just darken that in. Okay. Now, but we will also have this inner triangle that would look something more like this. Oh, okay, so see the A and the C? That would be my A and my C right there. But my B, instead of being here, now my B is here. Okay, and so my two sides are 150 here, and this would be that 125 we were talking about. And the angle A is 25. Okay, so these are the two triangles that I need to solve. Okay, now I'm just going to go ahead and clear this out because I'm going to need the space. Okay, let's go ahead and solve the blue triangle. What are the pieces of information I'm going to need? I've got angle A. I'm going to need the measure of angle B and the measure of angle C and side C. Once I have found all three of those, I will have solved the blue triangle. Okay, so I have this angle and I have this opposite side, so I can think about doing the law of sines. So that would be sine 25 over 125 is equal to, so I want to find angle B, so I'm going to say sine of angle B over its opposite side, 150. Now I could get sine B by itself if I just multiply both sides by 150. Okay, that way these 150s will cancel each other out. So this gives me the sine of B equals all of this. But I want the actual angle B, not just the sine of B. So if I want angle B out of this, I need to do the inverse sine. So I need to do the inverse sine of all of this. And that should give me angle B. I'm just going to put all this in my calculator. All right, so that's giving me 30.474. Now, okay, so that was B. I can easily find angle C by subtracting these two from 180. That gives me 124.526. Okay, so now we just need to find side C. So we can just do the law of sines one more time. So here I'm going to use the same ratio I did before. So sine 25 over 125 is equal to whoops, I almost wrote sine B again. That's not what I need this time. Okay, oh, so we know that angle C now is 124.526. So I can do sine 124.526 over C. So cross multiplying, I get C sine 25 is equal to 125 sine 124.526. Then I will divide both sides by sine 25. So these will cancel out, I'm just going to put all this in my calculator, and that should give me side C. So side C turns out to be 243.680. So that's one triangle. So now let's solve the other triangle. And again, looking at this triangle, we are missing angle C. So we're going to need to find the measure of angle C. We're missing angle B. And we are missing side C. So to solve this triangle, we will need to find these three quantities. So the bottom line is going to be that the acute angle B that we found before and the obtuse angle B that we're about to find now are supplementary. They are going to add up to 180. So if I want to find the obtuse angle B, I can just do 180 minus acute angle B. And that's going to give me obtuse angle B. Okay, so if I do that, I'm going to get 149. You know what, maybe I'll write it here first. So I can write it nice and big, 149.526. Okay, now one more time, the reason why that is. Remember that we formed two triangles because the swing side that I've shown here as a dotted line could be here, or it could swing inward and be here. So when we solved the first triangle, we looked at the swing side as being in this position, and we found this angle was 30.474 degrees. Now we're imagining swinging this side inward, and it's going to be here. But of course, these are the same length. So this side A, was 125. So this is 125. But this side here in red is the same side. We're just swinging it inward. So this is also 125. So what we have is an isosceles triangle. So it makes sense that if this angle is 30.474, then this angle right here is also 30.474. Okay, these are base angles of an isosceles triangle. And that's why this angle, this obtuse angle, is supplementary to this. That's why we find this angle by subtracting from 180. Because this is a straight line. It's a straight angle. So together it's 180 degrees. So that's why 149.526. So I don't want you to have to go through this analysis every single time with the isosceles triangle. I want you to see it once right now, but then as we go forward, you're going to know that this, anytime we have two triangles formed in this way, because of the swing side fitting in both positions, the acute angle and the obtuse angle will always be supplementary for this same reason. So ultimately, to find the obtuse version of it, we will just subtract from 180 as a shortcut. Anyway, now that we have two angles, we can easily find the third by subtracting from 180. So I'm just going to do that off camera, but I'm going to take 180 minus 25 minus 149.526, and that should give me angle C. And that turns out to be 5.474 degrees. Okay, so that just leaves side C. So for that, we're going to have to do the law of sines. Okay, so let's see, what do we have? Angle B and side B are, we have both of those, so let's start off using those values. So if I say, I think this time I'm going to do the side over the sine angle. So side B is 150 over the sine of angle B, which is 149.526. All right, make sure you are using 3 decimal places. And that should equal side over sine angle for another pair. So obviously I'm looking for side C, so I'm going to do side C over the sine of angle C, which is what we just found, 5.474. Okay, so now I can solve this law of sines by multiplying both sides by sine 5.474. So I'm going to do sine 5.474 on both sides. Alright, that way these will cancel each other out. And that is going to give me side C. So I'm just going to put all of this in my calculator all at once, and that should give me the answer. So I'm getting 28.215. And that is how you solve the second triangle. So don't forget, we had 2 solutions for this. Because of the ambiguous case, we had 2 versions of the triangle. This is one solution here in blue, and here's the other solution here in red. Okay, let's move on to number 6. Let's keep on practicing. Okay, again, as soon as I see that we have a side, and an angle, I am going to wonder about the ambiguous case. Draw it this way. Go ahead and make a horizontal line and draw your angle like this. Think of this as a hinge and make this your swing side. We don't know if it'll really make a triangle. We don't know if it'll make 2 triangles. Maybe it'll swing in. This is the swing side, and this is the rigid side. But we will put the one angle that we have right here in the left corner. So this will be my 42 degrees. That's going to make this angle A. That makes this side A, so that'll be my 22 right here. So I have angle A, and I have side A is my swing side. The other side is going to be the rigid side. So I will put the 12 here on the rigid side. So that is side C, which makes this angle C, which means this must be angle B up top. So the first thing we have to decide is, will this form a triangle at all? And the way that we will figure that out is by looking at the height. Okay, let's look at the height and decide if this will form a triangle at all. So looking at angle 42, the sine of 42, that's opposite over hypotenuse, so that will equal h over 12. Multiplying both sides by 12, I'm going to get 12 sine 42 is equal to this height. And then I'm just going to punch this in my calculator real quick. So 12 sine 42, okay, that's giving me 8.03. Alright, so this is 8.03 for my height. So will this form a triangle? In other words, if you think of this swing side as a rope, will the rope reach all the way from B to C? And yes, of course it will, because this height is only, it's about 8, and the rope is 22. So that's plenty long enough to reach, so it will form a triangle. So far we've shown that we will have at least one triangle, and it's this triangle the way I have it drawn. The question is, will it also form a second triangle? And the way that it might form another triangle would be if the swing side would fit this way. If we took this rope and we swung it inward, would it fit right here as well to form a second triangle? So that would make this 22 be right here. Well, no, this won't work, because this side, the rigid side, is 12. 22 is much bigger than that. So that would mean that this 22 is going to stretch outside of the triangle because it's bigger than 12. There's no way it can be contained within. So we cannot form a second triangle out of this. So we just have the one triangle this time. Alright, so this is the only triangle, so this will be relatively simple, and I can just go ahead and solve it. Okay, I'm just going to erase this to get my space back. So let's go ahead and list out the things that we need to find. We need to find the measure of angle B. That's missing. We're going to need to find the measure of angle C. And we're going to need to find this side, and if that's angle B, that makes this side B. So to solve the triangle, the only triangle, we will need these three pieces of information. So, looking for an angle and an opposite side, I see that we have these. So I'm going to go ahead and set up my law of sines like this. I will say the sine of angle A over side A. Okay, now I will do another sine angle and side. Now the other number I have is 12, so I'm going to have to use that. And so that's side C, so now I'll do the sine of angle C in the numerator, so sine of angle C. I should be able to use this to find angle C. So of course I'm going to multiply both sides by 12 in order to do that. So these 12s will cancel out. So that'll leave me sine C is equal to all this. Now if I want the angle out of this, I need to do the inverse sine. Okay, so the inverse sine of all of this should equal angle C. So I'm just going to put all of this entire expression into my calculator. Notice how I didn't make little decimals as I went along. You should be putting this whole thing into your calculator in this form. So I got 21.406 for angle C. So I got 21.406 degrees and 21.406. I have two angles, so I can easily find the third by subtracting from 180. So I'm just going to take 180 minus 42 minus 21.406, and that should give me the measure angle B. So I got 116.594. Okay, that just leaves side B that I need to find. Okay, so I'm going to set up my law of sines again. Now I'm using a little rule of thumb here, and I've been doing it in my head, something I've recently decided. You know that when we do the law of sines, it doesn't matter whether I do sine of A over A, equals sine B over B. I can do this version, or I could do the reciprocal of that, and I could do side A over sine of angle A is equal to side B over the sine of angle B. Either version of the law of sines is fine. Now, so what I've decided is whatever quantity I'm looking for, I'm going to put it in the numerator, and that will save me a step. So, for example, on the last step, when I was looking for angle C, I put the sine of angle C in the numerator because that made it easier to solve. I didn't have to cross multiply. All I had to do was multiply by 12. This time I'm looking for side B. So I want side B in the numerator. That'll save me a step. So if you're wondering why I'm on the previous step I did sine angle in the top, but now suddenly I'm putting sides in the top, that's why. Whichever thing I'm looking for, that's what I'm going to put in the numerator from now on. Okay, so I'm looking for side B, so that's going to go in the top. And in the bottom, I'm going to put the sine of angle B, which is 116.594. And over here, I'm going to use the same pair that we've had from the beginning, but this time I'm going to put side A in the top and the sine of angle A in the bottom to match. So now I don't need to cross multiply, so it just saves me one step, that's all. So I can get B by itself by doing by multiplying both sides by the sine of 116.594. Okay, so these will cancel out, and that will leave B. So I can just put this entire expression in my calculator, and that will give me side B. So I got 29.400. It was actually 29.3999. But if I round to the nearest thousandth, that would be 29.400. So that's it. That is the solution, the one and only solution for number 6.